All right, guys, I know I got cut off. But anyways, we were just finishing up writing on the worksheet just those highest level principal energy level S&P electrons. So that would be the N equals 3 S&P electrons. And there are 5 here. So I want to show you this, which can look a little bit overwhelming, and I just wanted to show it to you for you to appreciate that the entire periodic table is based on the quantum numbers. So this is what we call the S block. The middle part is the D block. And then the far right is the P, and the part that's underneath is called the F block. So remember when I taught you the principal quantum number, that's equal to the period or row within the periodic table. And then the other thing is that the spin and also the number of orbitals. So remember D has 5 ways that it can be in space. So 5 orbitals, but 5 times 2 electrons in each would give me 10 electrons total. And if you count here, it's 10 wide. The P, remember P has 3 orbitals. Each can have 2 electrons for up to 6 electrons. This is 6 wide. F has 7 orbitals, can hold up to 14 electrons. Again, 14 wide. And then S has just 1 orbital, and you can hold up to 2 electrons, so it's only 2 wide. So let me show you a little bit easier to read. And you could do this, you can add this to your periodic table. What I'm going to show you is so we have our N equals 1, 2, 3, and then remember this is really 6 and 7 we'll do. And then this would be S1, S2. This would be D1, D10. This would be P1. And then neon, it would go P2, P3, P4. Same with this. It goes D2, D3, and so on. P5 and P6. Helium is really S2. So what does this mean? It's really cool. So if I want to write the electron configuration for atomic number 3, which is lithium, what I do is I start reading this left to right. So I would write 1s2, because those first 2 electrons are in the first main energy level in the S sublevel. And then I would come down here to 2s1. So that would be the configuration for lithium. I'm going to show you as they get bigger that this is really cool. Okay, so my Aufbau for my highest energy level is N equals 2. So I would do, this would be my 2s. There are no 2p electrons in this one example, and then I just have that 1 electron. So let me show you another. So this is the next one, and we're going to do atomic number 19. So we're going to go to potassium. And again, I'm going to read it like a book, left to right, top to bottom. So I would go across, and I would say 1s2. So the first 2 electrons go in that first sphere that's closest, N equals 1 to the nucleus. Then I would write 2s2. So the next 2 electrons go in another sphere, so that's a little bit bigger. Then I go across 2p, and there's 1, 2, 3, 4, 5, 6, so 2p6. Then I come down here, 3s1, 3s2, sorry. It would be 3s1 if I was doing sodium, and then I'd be done. But I'm going to keep going. And then I come across 3p. P can only hold up to 6, no more. And then I would get here, which is, remember my N is 1, 2, 3, 4. So that would be 4s1. So I'm not going to do this part. You would bring that down, and then this would be your highest N value is 4. S and P, there's no P. So this would be 4s and that 1 electron. Let me show you another. So this is 32. So here's its germanium. So this one we're going to go through the D's and you're going to see what happens there. I'm going to write something above the S block. I'm going to write N. Above the P block, N. Above the D block is N minus 1. And above the F is N minus 2. So let me show you how that works. So germanium, I would go through my first 2 electrons, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. It's getting longer. Now when I get to the D's, it's going to drop down to 3D. And then I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. If it was 9, if it was copper, I would have just stopped with 3D9. But I'm going to go all the way through the D. So I'm going to write a 10. And then I'm going to pop back out and I'm still in N. So that these guys are N. These guys are N minus 1, the D block. So then I pop back out. I'm still in N is 4, 4p2. So let me show you why that overlapping is. If you look at the Aufbau diagram, it's easier to see. You don't need to memorize it as long as you know that when you get to the D, you go down, N minus 1. But look at this shows you also. So you go 1s, 2s, 2p, 3s, 3p. So look at where the 3p is. But then the 4s is slightly less in energy than the 3d. And we're using Aufbau's principle where we fill the orbitals with the lowest energy first. So we would actually go to 4s and then go back to 3d. So that when we use the periodic table, though, it just happens as you're reading it. So we get to 3s, we do our 3p's, and then the 4s comes first, which means it has less energy in the 4s than the 3d's do. So that's all I have. I'll have you guys practice. I'll teach you more about this in another video or in class.